2 years ago, in class on a blustery November day, I let my students screw off and watch Chasing Ice, James Balog's documentary on diminishing ice masses across the planet. Since that time, I've had the ultimate pleasure of having students on fire. I teach at a community college in central Wyoming. We're conveniently positioned on the flanks of the Greater Yellowstone ecosystem, and you can advance that any time if that's okay. There we go. And above us, alpine rock and ice as far as the eye can see, and the seeds for 3 major water resource regions. 63 glaciers, 680 at last count, snow and ice bodies, and we know, without a doubt, the hypothesis was never whether or not they were receding. We know they're going, gone. What we don't exactly know are all of the hydrological and ecological implications of their loss and contributing factors outside of temperature change. I strongly believe, as an educator, my role is to inspire, to engage, inform my students. And in this case, I needed to take something of great contemporary scientific concern and match it with my students' passions. Together we met on higher ground, common ground in the high alpine of the Wind River Range of Wyoming. I believe if you want to engage students in hypotheses-based research, you have to start them young, as early as possible in their academic careers. It's too late to write your first hypotheses when you hit graduate school. So we built it, and they came. 600 pounds of food, research gear, and film gear, 60-pound packs on 13 students, and 3 faculty from outdoor education, environmental science, and archaeology. We traveled collectively 21 miles into the backcountry, strapped on our crampons, our ice axes, and the only thing harder than getting that crew to that point is finding funding. Thank you, NASA. Thank you, NSF, Export YK, and Wyoming Public Broadcasting Service. Happily, our funders recognize that it's not just a scientific issue that's of concern, but the development of interdisciplinary, field skill, GIS-savvy field researchers. For the water we're looking at in this instance is not Wyoming's water. It's not the Wind River Indian Reservation's water. It's not Fremont County's water. This is the nation's water. Our suite of glaciers sits atop the Continental Divide and feeds the Upper Colorado, the Pacific Northwest, and the Missouri watersheds. This is the nation's water. And as we advance throughout time, we look back at these statistics and say, oh, this data that says these glaciers provide, I don't know, between 3 and 25% of the state's water. Those statistics are currently under great scrutiny. The problem is here, the time is now, and we believe that data is actually very, very conservative. So we have our students take their wilderness first aid skills, their mountaineering skills, take the glaciers that sit atop the campus, put the boots on the ground, and head into the backcountry to not just take other people's data or remotely sensed data, but their own data from on the ground. Some of it's pretty straightforward. This past summer, we added some water quality data to our suite, and we included E. coli. This was a project we worked on with the U.S. Forest Service, and taps into the fact that a team of 20, which we ultimately were, with everyone included, plus all the climbers who visit Canada Peak, Wyoming's highest peak in the summer, all poop. With leave no trace, pack it in, pack it out. The question will soon be how much you take out with you in portable fecal bags. So that was something we contributed to the state this summer. We also work with the American Climate Science Program, collecting snow samples for black carbon analysis. So far, our data shows that comparatively across the nation, we are somewhat average, but for a wilderness with a capital W designated area, we are high. Mapping the perimeter, for the public, this is a perfectly digestible way of looking at glacial advance and glacial recession. It's not truthfully the data we're seeking. We're looking for depth to bedrock, we're looking for changes in elevation, but it provides our students with hands-on opportunities to collect data that has meaning. GPR, on the other hand, is sexy. Ground-penetrating radar, students in crampons, cute phases, and you have a story to tell. This summer we used a 100 megahertz antenna, And we did get excellent data. Last year was a full bust. This year we got depth to bedrock, and we are ecstatic. That 1 kilometer, 1.5 kilometer transect took 2.5 field days, 5 students working flat out at 11,000 feet. They train and train. Archaeology team blew it out of the water this year. Potential close point, possibly the highest Buffalo drivetrain in North America, and a new addition to our expedition this year, showing that people have been chasing ice for the last 12,000 years. And so we crossed the Great Divide between students with head in hands and hearts in their throat, between glaciers and water, between watersheds, between receding glaciers and advancing students and students on fire. Thank you.